4b. Okay. Here, my angle on the left is a 2t, and my angle on the right are single t's. I can't just divide off the 2 because I can't ever change an angle. So what I can do though, right, is write it as the tangent of 2t is write it as the tangent of t plus t. And then we're going to use our formula. So that says the tangent of the first plus the tangent of the second over 1 minus the tangent of the first times the tangent of the second. Okay, so the tops together, since they're really identical, we can write that as 2 tangent t, which is good. That's the numerator we're going towards. And the bottom, just 1 minus a tangent times a tangent is a tangent squared. And we call that done. So adding a tangent and tangent makes a 2 tangent t. Multiplying a tangent times a tangent makes a tangent squared. Okay, so let me just take 1 second note. When I add this 2 together right here, notice it doesn't make tangent of 2t. Where the 2 goes is out front. It's basically like if you have x plus x, you have 2x. The 2 goes out front. So that's why the 2 is going out front right there. Okay. Anytime you want to work with your angle, if you have a number attached to your angle, that's only referring to rotations. That's all it does. This next one, I have 2 fractions, and I'm making one very large term. So these 2 fractions have to come together because I'm making one very large term. So let's start there. I have sine of 7t, and I want to get a common denominator, so we're going to write it as sine of t times cosine of t because they're very unique. So to make a common denominator, we're just going to multiply them together. And that first fraction, the denominator was a sine t, now it's a sine cosine, so I need to add or multiply in the cosine to the top as well. The second fraction had a cosine t in the bottom, it was missing the sine t, so I've got to multiply that to the top as well. Okay, so we have a common denominator of sine t and cosine t. That's great. Let's look at the numerators. We want to eventually add them up. It goes sine, cosine, cosine, sine. The first angle is 7t and 7t. The second angle is t and t. So this is going to be the sine formula with the first angle. Here's the second angle. It's connected with a plus, so we're going to connect it with a plus right there. And again, if you want to, start right there, and if you want to expand it from here, it's the sine of the first, cosine of the second, times the cosine of the first and sine of the second. And you've got that whole top written out right there for you. So this makes together a sine of 8t in the top over a sine of t times a cosine of t. Alright, now how am I going to get to my answer? Well, the easiest way I can show you is to kind of write it out. Would you agree that what we're just looking at right here is the same thing as going 1 over sine t times 1 over cosine t? So sine 8t over 1 over sine t. In other words, if I combine these 3 fractions together, since they're all multiplied together, sine of 8t times 1 is sine of 8t. 1 times sine t times cosine t will get you right back to there. Well, this first part, let's just leave it as sine of 8t. What's 1 over sine is cosecant. 1 over cosine is secant. And there's my answer. All 3 written together. So they're kind of hidden when they're in there, but you realize you actually have your answer. You're just rewriting as 1 over sine as cosecant and 1 over cosine as secant. That's all you had to do. Okay. Before we get started on this next example, where we're showing this one, I want to show you guys there's a tiny little typo right here, up here in the top of this. What we should be equaling is secant x cosecant y, and the bottom is still the same. So tangent x cotangent y minus 1. So if you'll make sure you replace that secant y with cosecant y, then we can get this problem started. I just had it written down wrong in your notes. So, okay. Over here on the left, we have an angle that has x minus y. All the angles on the right are just single x's and y's. I don't know an expansion for cosecant, but I do know that cosecant relates to sine in the sense it's 1 over. So I can write this as 1 over sine, and then do my expansion for sine y. Oops, and sine y right there. Okay, and now what we're going to do to get our next step is that we want to look at this really closely. Okay, my goal is I have one fraction going to one fraction. I've got one term in the top going to one term. I've got two terms here in the bottom going to two terms. Remember, just like we did in this last section, the last couple sections, is that whenever this happens, you're going to be multiplying the top and the bottom of your fraction by the exact same thing. And what is that going to be? Well, let's go to our 1. I need 1. And what do I multiply 1 by to get secant x cosecant y? Well, it's pretty obvious. Secant x cosecant y. So let's do this both to the top and the bottom and see what we get at. So here on the top, it'll be our secant x cosecant y, which is great because that's where we want it to be. There's half the answer. So down here in the bottom, sine x cosine y times our secant x cosecant y minus cosine x sine y, what was originally there, times what we're multiplying by, secant x cosecant y. So when you have several terms multiplied together, what you want to do is pair them up. X to x. What's sine times secant? Well, sine secant is 1 over cosine. So sine times 1 over cosine is going to be tangent. All right, so up in the top we have our secant x cosecant y, and in the bottom x to x, so sine times 1 over cosine, we said was tangent, and x, because that's our angle connected, cosine y times cosecant y. So cosine y times cosecant, and cosecant is 1 over sine. Well, cosine x divided by y is cotangent. So those cotangent y. Match x to x. It's cosine times secant. That's your x value times your 1 over x, which is 1. So those multiply together, give you a 1. Sine y, cosecant y, that's 1. That's 1, or sine times its reciprocal also gives you 1. So together they make 1. And we can check this one off. We are done with that problem. All right, 4e. Oh, this is a tricky one. I remember this one. Can I tell you the number of times in the past where I've tried to do this on the board and I always mess up, because this one's a kind of a tricky one. Because when you look at this, your first goal is like, ooh, I'm going to expand that. Ooh, I'm going to expand that. And just know that I'm probably not going to trick you up on the test, but this one's kind of a fun one because you're just like, ooh, I never saw that. That's evil. Okay, let's look at our first angle. See, our first angle is x plus y, and our first angle over here is x plus y. Our second angle is y, our second angle is y. Look how it goes, sine, cosine, cosine, sine. So this is really the sine formula, where my first angle is x plus y, my second angle is y, and what connects the two of them together is a minus sign. It's very, very tricky. So x plus y minus y is just x, and we are done. Look at that. In 2 steps, you were done with this identity. So like I said, it's kind of a tricky one. My first reaction every time to do this is always, ooh, let's expand the sine. Let's expand the cosine. And it gets me every single time, but I got it this time. All right. Okay, with this one, this is also a tricky one, but I'm going to give you guys a little heads up. So just kind of follow me through this one. What I'm really going to write this is that instead of tangent, I'm expanding the tangent one. The easiest way I saw this is I'm going to write it as the sine of x plus y over the cosine of x plus y times the sine of x minus y over the cosine of x minus y. And the reason why I'm choosing to do the sine and cosine expansions as opposed to the tangent one is just because everything on the right is cosine and sine, and it just helped me see it easier. Okay, so now let's go through and expand. So we'll have sine of x cosine of y plus cosine of x sine of y all over cosine x cosine y minus sine x sine y. So this is kind of nothing else, giving you a really good going back and practicing all your formulas for sure. Over here on the right, we'll get sine of x cosine of y minus cosine of x sine of y all over cosine x cosine y plus sine x sine y. Okay, so what we're going to do is in the top multiply two terms to two terms, and in the bottom two terms to two terms. And if we notice, the front terms always match up, the back terms always match up, they just differ by center sign, so that way I know I have conjugates, and all I really have to do is multiply the first and the last in all four cases. Okay, so sine x, cosine y makes a sine squared x, cosine squared y, plus minus is minus, then a cosine squared x, sine squared y. All right, in the denominator, cosine x cosine y times cosine x cosine y is cosine squared x, cosine squared y, minus sine squared x, sine squared y. All right. Take 2 seconds. Let's look to our answer. Our answer has the top left term as just cosine squared y. So it's this one right here. The top right one has just cosine squared x, so that one right there. And then bottom left has cosine squared y, and the bottom right is sine squared x. Okay, what I want to do is the ones I've arrowed, I want to leave right where they are. The ones that aren't arrowed, I want to replace them with a trig identity. And it's either going to be the 1 minus sine squared or the 1 minus cosine squared. Okay? So in that top left, the sine squared x is going to get replaced with 1 minus cosine squared x. And again, I'm going to leave that cosine squared y right there. The one with the arrow I'm going to leave, so cosine squared x, and the sine squared, I'm going to write it as 1 minus cosine squared, and this time the angle's y. All right, over, I'm going to do the same thing in the denominator. The cosine squared x is going to be replaced with 1 minus sine squared x. I'm going to leave that cosine squared y right there. The sine squared x is going to stay right where it is, and I'm going to replace the other one with 1 minus cosine squared y. Okay, so let's FOIL off and kind of give myself a little some break right there. Let's distribute along the top, and let's distribute along the bottom. Okay, so on the top, cosine squared y times 1 and then to the other one. Let's see if I'm afraid I might run out of room, but we'll see what we can do here. So cosine squared y minus cosine squared x, cosine squared y minus cosine squared x plus cosine squared x cosine squared y all over, and then here's my denominator. I have cosine squared y minus sine squared x cosine squared y minus sine squared x plus sine squared x cosine squared y. So hopefully y'all can kind of follow me here this little bit. Okay, up here in the top I have a negative cosine squared x and a cosine squared y, and then a positive, so those two go away. Down here I've got a negative one and a positive one, and they go away just by matching x to x, y to y. Same thing in the top. So what's left in the top is a cosine squared y minus a cosine squared x, and in the bottom cosine squared y minus sine squared x, and we have our answer.